Hello all, my name is Debanjan Chaudhary and welcome to my YouTube channel. In this particular video, we are going to continue with set theory. Okay, so in my last video, I had given an introductory understanding to what is set theory. Today we are going to continue further with set theory. So I would ask you to please go and visit my previous video in set theory, the link of which is given in the description section below. It will help you to understand this particular video in a much better way. Okay, so let us begin with this video. Okay, so in this particular video we are going to understand about two topics. Okay, so first thing is we are going to understand about some important sets, and the secondly we are going to understand about the types of sets. Okay, so let us begin with the first subtopic, right? That is some important sets. Okay, so firstly, okay, there are various types of sets, some of which I'll be discussing. Number one, we have got the set of natural numbers. Okay, it is denoted by capital N. Okay, so N denotes natural numbers. Natural numbers. Now, what are natural numbers? Natural numbers are numbers which start from 1, okay, then it goes till infinity. For example, 1, 2, 3, 4, okay. In this way, it's going to go till infinity. These are natural numbers, okay. Secondly, we are going to understand what are integers. Okay, so integers are basically denoted by z. Okay, so z means integers. Now what are integers? Integers are nothing but set of numbers, right, which starts from this minus infinity, then it's going to go till minus 3, minus 2, minus 1, then 0, then 1, 2, 3, and then it's going to go to plus infinity. So from minus infinity to plus infinity, all the numbers, right, like minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, these belongs to the set of integers. Then thirdly, we are going to understand what we mean by positive integers. Okay, so it's denoted by z and a plus. Okay, it means positive integers. Okay, now understand that positive integers z plus and natural numbers n are used interchangeably, so they don't have different meanings, they are same. Okay, so positive integers also start from 1, 2, 3 and it's going to go till infinity. Okay, so these are positive integers. Next we have got something called as rational numbers. Okay, okay, so we have got something called as rational numbers, that is denoted by q. Okay, q denotes rational numbers. Now what is a rational number? So the definition of rational number says that it is a number which is represented in the form of a ratio of p by q, okay, where q is not equals to 0, right? Now let us try to understand with some example. For example, if I write say p is 4 and q is 2, this is a rational number and it can be written as 2 because 4 when divided by 2 gives us 2. If I write 3 by 2, okay, I can get 1.5, right? This is also a rational number. Similarly, any other number which is recurring, right? For example, 3.767676, okay, in this way. This is also an example of rational number, okay? Any recurring number is an example of rational number. So we have understood, what is a rational number. So similarly, set of rational numbers can be written in this way. Okay, so 2, 3, 1.5, 7.6767, right? In this way, then 8.34. These are all set of rational numbers, right? Now, what is the difference between a rational number and a irrational number? So an irrational number cannot be written in this form, okay? It cannot be written in the form of a rational number. For example, a number like pi, okay? It is a irrational number. Why? Because its value is 3.14, then 16, then in this way it's going to continue, right? It is not recurring, okay? For example, if a recurring number is like 3.7676, okay, we can say that it's a recurring number because 7676 is going to continue. But in case of pi, this 3.1416, and it's not going to recur. It's going to at every value the number is going to be different, right? So this pi is a irrational number. Similarly, root of 5, okay, square root of 5 is also an example of an irrational number, right? So I hope you are able to understand what is the difference between a rational and an irrational number. Now we have got something called as a set of whole numbers, okay? Whole numbers. So a whole number is a number, or a set of whole numbers are numbers which includes all the natural numbers 1, 2, 3, okay, till infinity, plus it includes 0, okay. So whole number includes 0, then all the and then the set of all natural numbers. So I hope you are able to understand the sets, okay, some types of sets. Now some kinds of sets. Now we are going to understand our next topic, which is nothing but types of sets, okay. So here firstly we have got something called as finite set, okay. So what do you mean by a finite set? Obviously finite means it is definite, right? So a set which has got finite number of elements is basically known as a finite set. For example, if I write it in the set builder form, which we have discussed in our last video, right? So it's like, say X, a set S such that X is greater than 10 but less than 20, okay. X greater than 10 and less than 20, this is a finite set. Why? Because if you write it in the roster form, right, we'll have 11, 12, 13, 14, 15, 16, 17, 18 and 19, right? And you can see that it is definite, okay, it's ending in 19, starting from 11 ends at 19, right? That means it's a finite set. Secondly, we have got something called as infinite set. Okay, so what is an infinite set? It's similar to finite set, right? Any set which has got infinite elements, right? It's an infinite set. For example, say X such that X modulus 2, okay, is equals to 0 and X belongs to the set of natural numbers, right? So what will be the roster form? It will be 2, 4, 6, 8, 10. In this way it's going to go till infinity, right? So infinity means indefinite, right? So we can say that this set is an infinite set. Thirdly, we are going to understand what do you mean by a subset. So let us try to understand with the help of an example. See, we have a set Y and we write it 1, 2, 3 and 4. Similarly, we have a set X, okay, we write 2 and 3. Now just try to understand 2 and 3 are present in set Y, right? Because we can see 2 and 3 is here, and 2 and 3 is present in set X, okay. So we can say that set X is a subset of set Y. Okay. Now, how do you represent subset? We represented it this way. Okay. So this is said as X is a subset of Y. Now, how it is a subset? According to the definition of subset, if X is a subset of Y, it means that every element of X, okay, every element of this X is an element or belongs to set Y. For example, 2 and 3 is an element of set X and it belongs to set Y. So, it is called as a subset of Y. Similarly, let me give you some other example as well. Say Y is nothing but A, B, C and till Z. Okay. So, it is a set of all the alphabets. And say X is nothing but A, E, I, O, U. So it is a set of all the vowels, right? So then we can say that, X is a subset of Y, right? Because A, E, I, O, U is a set of, or it's basically a set of X, okay? And all the elements of this set X belongs to this set Y, is present in this set Y, right? Therefore, X is a subset of Y. Okay. Now, we have got something called as superset. Okay. So it's basically the opposite of subset. Okay. So obviously, if say X has got this 2 and 3, okay, and Y has got 1, 2, 3, right? Therefore, we know that X is nothing but a subset of Y. So Y will be a superset of X, right? Because it has got all the elements which X has got. Therefore, Y is nothing but the superset of X. Okay, I hope you are able to understand till this much, right? Now we are going to continue with our next topic, that is universal set. Okay, denoted by U. Okay, so what do you mean by universal set? It is basically the set of all the elements of a particular context. Okay, so say if I write U, okay, U is a set of, say, set of all vehicles. Okay, all vehicles. So it's a universal set of all vehicles. In this particular set, we consist of a set of all cars. We have a set of all cars, which is nothing but a subset of this universal set. We have got a set of all bikes, right? Similarly, we have got the set of all buses. We have got set of all aeroplanes, right? Similarly, in this way, we have got a set of many more things, right, which are nothing but belongs to the vehicle set. So a universal set is nothing but the set of all the elements of a particular context. In this case, the context is nothing but vehicle. So set of all vehicles is nothing but a universal set. In this, we have got cars, which are subset of U, bikes, buses, aeroplanes, and similarly many other things can be subset of U, right? So I hope you are able to understand what is a universal set. Now we are going to understand what do you mean by a null set or an empty set. Okay, so what is a null set? Null set, it is basically denoted by this symbol called as phi, right? This has been written in this way, phi. Okay, so let me give you an example. Say X is a set where small x such that x belongs to n, that is a set of natural numbers, and x is greater than 1 but less than 2. So what are the set of natural numbers? 1, 2, 3, 4 in this way, and the condition is x is greater than 1 and less than 2. So greater than 1 and less than 2, do we have any number in between it, right? No, because it is said that x belongs to natural numbers, right? And between 1 and 2, there are no other numbers which belongs to natural numbers. So what will be the set x? It's nothing but empty. So it's basically denoted by 5. Okay. It's basically denoted by 5. So I hope you are able to understand null set. And lastly, we need to understand what do we mean by singleton set. Okay. Singleton set. Okay. So a singleton set is nothing but a set which consists of only one element. Okay. Say for example, I write a set S where x such that x belongs to natural numbers and x is greater than 1 but less than 3. Okay. So obviously we know that the set of natural numbers consists of all these elements, right? And it is said that x is greater than 1 but less than 3. So between 1 and 3 we have got only one number, that is 2. So what is the set S? It's nothing but 2. It consists of one element 2, right? Therefore this set S is nothing but a singleton set. So I hope you are able to understand this particular topic of types of set and also the previous topic which I explained you in this particular video. I hope you like it. I hope you are able to understand all the topics which I am explaining you starting from my first video. If you have liked my video, please do like it and share it, and please do subscribe my channel. I'll be coming up with more such videos. Till then, stay safe, have a great day, and bye.